which came in the year 2019 in chemistry XLP, GATE XLP, and the question number was 12. So it came for 2 marks. The question states that a protein is denatured in a protein in denatured state D is in equilibrium with native state N. So at 360 Kelvin, both N and D states are equally populated. If the standard entropy change for the reaction at this temperature delta S naught is equals to minus 139 joule Kelvin inverse mole inverse, then the corresponding standard enthalpy change del H naught for the reaction in kilojoule per mole. Okay, so it is given a biological problem. So since we are all familiar with this topic, so I think they have formulated this question like this. So they have given that there is a denatured protein and also a protein in its native state, and they are in a equilibrium with one another. And at 360 Kelvin, they are telling that both N and D states are equally populated. Okay, so means the concentration of native state and concentration of denatured state of the protein is equal at 360 Kelvin. This statement means that if the standard entropy change for the reaction at this temperature is given, delta S naught value is given. So the change in entropy, the standard change in entropy is given as minus 139 joule per Kelvin per mole. Okay, so what they have asked to find the delta H naught. Okay, so you need some kind of relation where, for by looking into this question, something should come into your mind that you need some kind of relation where this both delta H naught and delta S naught are together and they are relating with one another. So for that, let us look into the theory part a little bit. So we know that Gibbs free energy. So if the Gibbs free energy is the energy that is available to do useful work. If the Gibbs free energy del G naught or del G value is less than 0, then this process or the reaction is known as exergonic reaction, which means the reaction is spontaneous in nature. And if it is greater than 0, then it is non-spontaneous or it is endergonic reaction. That reaction which is del G is greater than 0, that will not take place spontaneously. You have to carry out any spontaneous reaction which will actually circumpass that reaction which is non-spontaneous and somehow will balance the energy so that that non-spontaneous reaction can also occur. So that kind of process occurs in our body also. So in the formation of the DNA, this kind of processes occurs, but we are mostly concentrated on how the del G, the free energy, is related to two things. So first is the K equilibrium, the equilibrium dissociation equilibrium constant. Okay, so why equilibrium? Because in this question it is already said that your denatured state and the native state is in some kind of equilibrium, and if they are in an equilibrium, there will be an equilibrium constant for this equilibria. Okay, so what is this equilibrium constant? Or it can be also, if it is not in the equilibrium, then this K value can be also means considered as the reaction quotient. So the reaction quotient is given by this formula, that is concentration of the product to the power of their stoichiometric coefficients divided by the concentration the product the concentration of the reactants to the power of their stoichiometric coefficient. Okay, so here in this reaction, so you can see that the capital C is the concentration of the of your product, and the small c is the stoichiometric coefficient, and so it is written like this. So this Q, when it is in the equilibrium, they can be also represented as the K equilibrium value or the equilibrium constant. Okay, and that is K equilibrium is related to del G naught value. Okay, so why we are interested in calculating this del G naught in the first hand in this question? Because we know that this del G naught is related to both enthalpy and the standard entropy by this formula del H naught minus T delta S naught. Okay, So here it is already given, the temperature and the standard entropy is already given. If I come to know this value, delta del G naught, then it will be very easy to calculate this delta H naught. Okay, so by for that I am revising you this formula. So by looking into it, the first thing what you should do is that first thing is to find the K equilibrium. So since it is said, it is said in the question that at equilibria this concentration of both this native state and the denatured state, they both are equal. So when you take the K equilibrium, find the K equilibrium value, so it will be denatured state by native state or native state by denatured state. So it is equal to 1 because both of them are equal. Okay, so that is said in the question. So it should be native state by denatured state because the product here is the native state. Okay, but it doesn't matter, the value will be 1. Okay, because both of them are equal. And also we have the formula that del G naught is equals to minus RT ln K equilibrium. Okay, so from that we know that R value is already given, the gas constant, and the T value we it has been given in the question as 360 Kelvin. So just you need to put those values, and since ln 1, okay, so exponential logarithm 1 is equal to 0. So for that, this del G naught value will now become 0. Okay. So now if you put this in this equation, the standard free energy equation, where del G naught is equals to del H naught minus T del S naught. Since del G naught is 0, so you can directly get that del H naught is equals to minus T delta S naught. And again the values are already given, that is T value is given as 360 Kelvin and the del S naught value is given as minus 139 joule per mole. Okay, so it is already given, it is given as 139, but there is a negative sign in this formula. For that, this value final answer is in. So one thing you should remember, so in this kind of question what is very important is to look into that what unit, in which unit the answer is being asked. Okay, so if it is in joule per mole, so your answer will be that it should be in joule per mole. If it is kilojoule per mole, then you have to convert. If you find your answer in joule per mole, you need to convert it into kilojoule per mole, then write the answer. And also it has written that rounded off to 1 decimal place. Okay, so these things you should be very careful about because this sometimes cost you the marks because you have already solved the question but you have not read the question correctly, and so cautiously, that's why you will be losing some marks. So to avoid these silly mistakes you should read the question carefully. Okay, so the answer to this question will be minus 50 kilojoule per mole. So for your reference, what I have done is that means you can look into these two courses for getting some concepts in the thermodynamics part. So they are very good courses in NPTEL. And since it is a 1 hour class and I need to cover, means I am mostly solving questions and not going into the details of the derivations. So if some of you are interested, you can look into these courses in NPTEL. Okay.